Hey there, this is Jordan Schmidt, and I'll be presenting my project for data analytics. I'm actually super excited to get to show you guys my project. So I had actually submitted one about an hour ago, 2 hours ago, and I was looking through the code here, I was talking to some friends, and I realized where I could make some things more efficient. So before my old project, when I submitted before, I was able to do about one board. Like it took 10 minutes to simulate. It was taking a long time, and that was just one simulation. But I changed a couple things in um, my cross off card, so it just checks each square. Uh, and with these optimizations done, I'm actually able to simulate hundreds of boards a second now. I don't. It's like an order of magnitudes thing. I'm not exactly sure how it works, but it works a lot quicker now. Uh, and I'm gonna show you how it works here. So the program, we're just gonna start it down here in the corner. And so how many times do you want to simulate the boards? So we're just gonna go ahead. I'm just gonna put a flat 100 simulations. You can do 1,000. You can do whatever. But just for the sake of this, I'm gonna do 100 simulations. How many boards? Just for the sake of typing out all the boards, I'm only gonna do 3. But just like the other number, you can put as many as you want. It just takes a little time, but it doesn't matter. All right. So for the first board, what numbers do we want? Or if we're calling B, it doesn't really matter. Like it just has between 1 and 15. So right there, you see I was going to put 45. If I actually did end up putting 45 there, it would give me an error, and I'd have to correct it. I've typed these numbers in so many times, just testing the function and whatnot. 46, yeah, I think that sounds right. 48, 49, 50, yeah, it's 15 over. All right, 61, 62, 63, 64, 65. And like, granted, you probably wouldn't have a board like this in real bingo, but that's what this is. We can make your own board. All right, so you built the card, and so this is card 2. So we're gonna simulate a card. We're gonna put different numbers there. It can just be anything. It doesn't matter. So like, if you put wrong inputs, it should like give you error messages and whatnot. It's pretty user friendly without buttons. You can't see what I had air quotes there, but all right, for I, we should do 20, 22, 23, 24, 19, 35, 36, 38, 39, 40. It doesn't matter. Yeah, the concept's this. Like I say, it doesn't matter just because the concept's the same. Like whatever numbers you put in here, it doesn't matter. Like it does. You're gonna get different results, but the math and like the code is the same for whatever numbers these are. All right, 62, 63. All right, I'll have this code. I submitted the code already, so you can actually download this and run this for yourself. But it works. It's pretty cool. Almost. So the whole purpose of this is you can almost like hedge your bets a little bit. So if you want to go out and play, I don't know, bingo, and you're gonna go gamble $1 or whatever per board, your dollar get in, whatever it is. I should just type this at the top. 19, 22, 25, 27, 31, 35, 38, 37, 34. And like the middle end doesn't count, like that 38 there. It'll just get turned into an X for the free space. It doesn't matter. 51. This is honestly the most time-consuming part. It's just filling up the numbers. All right, so that's your third board built. So it's doing every single time. So I ran 100 simulations, right? So every simulation is going to generate a new seed, a new number, right? All right, so here's your numbers being generated. This is in our main function here. This is where we generate the seed here, and we throw the seed into the generator. So it generates all hundreds of numbers, and then it does the, let me scroll down to the bottom here. And so, yep, we ran the board 100 times. So this is actually really cool. So we got 28 times. So across our 3 boards that we simulated 100 times, we took the average. We compared each turn for each game. We compared the shortest. We found the shortest amount of turns for that game between the 3 boards. And then once we did that, we added that to a total. And then our total is just or average, I guess, is just our total divided by how many runs, and our runs is just how many times we simulated it. So reality, across 3 boards, we won in 28 turns for bingo, which I don't know if this is good or bad. I'm not a professional bingo player. Maybe I chose bad numbers. Maybe you can choose better. We hit that 5-minute mark though, but code completely works. It's super efficient, much better than the version I'd submitted earlier. I'm excited for you to take a look at it. Just let me know if you have any questions. Thank you so much.